What is going on, guys? Today we will be going over a pretty important LeetCode problem, and that's merge intervals. And in this problem, you're given an array of intervals, and you're supposed to merge all of the overlapping intervals. And what we want to be returning is an array of all of those non-overlapping intervals. So we're going to merge all the intervals if they're overlapping, and in the end, all of the intervals should be non-overlapping. And one thing to note here, and this pretty much goes for all interval questions, the very first thing you want to be asking your interviewer is are the intervals inclusive or non-inclusive? And we can see here from example 2 that they are inclusive because we have an interval 1, 4 and 4, 5, and we see the output is 1, 5. The second thing you want to be asking your interviewer is, are the intervals sorted? So in order to do this problem and a lot of interval problems, you need to make sure that you are processing the intervals in chronological order. And we see in this case that they're not necessarily going to be in chronological order. We have a 7, 8, then we have a 1, 3 here. So that means we have to go ahead and sort by the start times, and that way we can go ahead and loop through all the intervals easily. So here I have all of the intervals drawn out, and it's sorted by descending order right here. So we have 1, 2, 7, 8, and 15, and I drew it like that so it'd be easier to see where we're doing the merges. So we have 1 and 3, and that's our very first interval. So what you want to do is, since there are no overlaps, since it's the first interval, we just want to add that to our results. And now we move on to our next interval. We've already processed our first one. We move on to this second interval, and we have 2, 6. So we look at 2, and we compare it to 3, the value in our results, and we see that there's an overlap, right? So how do we know it's an overlap? It's because 2 is less than 3, which is the endpoint of the last interval. So we know there's an overlap. So what you want to do is you want to take this value here, which is the starting point of the last interval, and the endpoint of the current interval, and merge them. So once you get that, once you do that, you can update the res, and this 3 will become a 6. And moving on, we go to 7, 8. There's no overlap there, so we just add it to the res. And now we get to 8, 10, and we see that there is an overlap here. So then we want to update the res, and that becomes a 10 instead of an 8. And finally, we get to 15, 18, no overlaps, so we just add that to our result. Now, what if instead of having a 3, we had something like 10? And we'd look through here, and we would add that interval. And then we get to this value here, and we see that this whole interval is overlapping with our previous interval. So we want to do nothing in this case. We want to keep the 110. But what if this 6, instead of a 6, it was something like 11, right? Now we want to be updating it. So what we want to be doing is we want to be getting the max value of the endpoints and updating that. So in this case, this 10 would become an 11. And in our previous case, assuming that the interval is still 2, 6, we would just take the 10, and we would take the max value of 6 and 10, it would still be 10, and nothing changes. Time complexity of this problem is n log n, because we are sorting it. Space complexity is O of 1. So one thing to note here is we're not counting the res as space, because that's the answer we're trying to return. So first thing we do, we sort the array, and then we loop through all the intervals. And this condition right here is what checks to see if there's an overlap or not. If not res means that our answer array is empty. That means that's the first interval we're adding, so of course there's no overlap. And here we check the endpoint of the value we previously added, and we compare that to the start point of our current interval. And if that is less than our start point, then we know there's no overlap, and we just append to the res array. Otherwise, that means there is an overlap, and we have to update our res array. And we're updating it here. We're taking the max of the previous endpoint and the current endpoint of our interval that we're examining. And that's what we have here. And we're going to do that for every single interval and return res at the end. One thing I forgot to mention is space can possibly be O of log n. Technically it is O of log n because the sorting algorithm, once you sort it, it takes log n space. So you can say either in the interview, just clarify that the log n comes from sorting.